got a job to do for one of our customers at work. At least I volunteered to do a job for him. What happened, he had a puncture, and in most of your modern cars the wheels are held on with bolts instead of studs, and you're given this which screws into the stud hole and you lift the wheel on. That's plastic and it's pulled out and damaged the threads. It's not really strong enough for the job. So what I said I would do, I'll make him a steel one just to get the puncture. You can screw it in, slide his wheel on just to help him out. But the thread on this would be 14mm, 13.8, and the pitch is 1.5, so I've measured up with a thread pitch gauge. 14 by 1.5 is it's a strange thread, but it's a very popular thread on motor cars. So all I need is a bit of steel bar, turning down to just below 14mm with a 14 by 1.5 on the thread on the end of it. Thread gauge fits in very nicely. Focus. That's it there. I'm going to take this chuck off and put a collar chuck on just because it's easier for me to get some video with the camera. I haven't got the bulk of the chuck in the way and I'm not in a hurry, so I'll put the collar chuck on. Just make sure this tape is nice and clean. No little bits of swap anywhere in there. A little bit of lubricant won't hurt. Oh dear me, Johnny. This is actually stainless. Just what I happen to have lying around. It doesn't need to be stainless, but it's what I'm going to use. Ready. That's 15mm and that's 13.8, so at 1.2 of it, and dial in 0.6. Nasty, horrible, stringy chips it's making. Machine a small groove for the screw cutting tool to end up in. As you can see, this parting tool is still going strong. this is the tool I'm going to use to cut the thread. It's a commercial thread cutting tool, a proper tool to cut 1.5 pitch. I've made sure it's set on centre height. It's also important that the tool is set at 90 degrees to the job, which is simple enough by using a square like that. Right, so it's on centre height, it's at 90 degrees to the job. The normal method for cutting metric is to put it in at a 30-degree angle, but with these inserts you can go straight in. It's just a shallow thread and just cut the thread. So just put the feed on with a cross slide. When the shoulder of the tool, that part there, touches the job, that's the thread done, finished, full depth. It's just a case now of setting up the gearbox and cutting a 1.5mm pitch thread, which is easy because this is a metric lathe. Right, they're the change wheels I've got in. They're the ones that stop in there all the time, or unless I'm cutting imperial. So we'll find a 1.5mm pitch, which is that one. So move that into 1.5. It'll go in once the lathe starts to move, once it turns a little bit. And it shows the position of the 3 gear selectors. So the right hand lever, which is that one, goes that way, which it is. Then it's showing 1.5. It's showing them both forward like that. So it's forward, 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 and that's in the 1.5. I've got those change wheels in, so it's going to cut a 1.5mm thread. This thread navigator can be engaged on any line and the thread will pick up automatically because it is a metric lead screw, so I haven't really got to worry about it. Any line, to engage it and it will cut the 1.5mm pitch, starting at exactly the same place. Right, everything's set up. I'm going to zero the cross slide, put a light cut on just so it scratches the surface, engage the feed nut. Get to the end, we'll disengage, that's it. Zero the cross slide, wind it out, back to the beginning. Right, we'll have a measure of the pitch just to make sure it is cutting 1.5, it looks good. It's absolutely spot on, 1.5. Right, so put some more cut on. Engage on any line again. It's cutting the same thread, that must be good. Zero, wind it out into zero, and some more cut. And that'll be his last cut. Right, that's a much better looking affair, but it probably costs 100 times more than that one. Next we need a hole drilling in the end, the same as that, and you put in the screwdriver you get with a car just to screw it in and out. So we'll set it up in the face on the milling machine and just drill that hole. Parallel in just to keep it nice and straight. Find the centre and drill it. Not that critical, so we'll be able to get it very near using this. There, that looks pretty good. It often takes to use a milling cutter and just mill a flat on there to get the drill to start, but I think the centre drill should start on it alright. We shall find out. Yeah, it is. Use cobalt drills. I've actually got a set of Banggood cobalt drills coming to evaluate. It'll be interesting to see what they're like compared to the cheap and cheery high speed ones I did last week. We have to be good to beat these. The dreaded belt noise has come to join us again. Edges off that drill. Once you start cutting, you stop using them and sharpen them straight away, otherwise you'll roll them because they get hot. See the difference? Between a blunt drill and a sharp drill.